Welcome to the deep dive. Today we're tackling something called failure mode and effects analysis.
Right.
FMEA.
FMEA.
You shared some really great resources, and they show how vital this is. You see it in healthcare, manufacturing, lots of places.
Yeah, it's pretty widespread.
So our mission today is to kind of cut through the jargon, right? Explain what FMEA is, why you'd want to know about it, and how it actually works.
Yeah.
Without, getting totally bogged down.
Exactly. And the sources we have are quite varied. We've got stuff explaining the basics, how it's used to boost quality in hospitals, for example, and also how it's linking up with like digital manufacturing now, plus information from groups like JCI and NABH, the hospital accreditation bodies.
Right, the quality standards people.
Yeah. They don't always scream FMEA, but their focus on quality and safety, it definitely hints at needing these kinds of proactive tools.
Got it. So for the listener, what's the main takeaway? What's the benefit here?
Well, by the end of this, you should really see FMEA as this powerful way to, get ahead of problems before they happen.
Proactive, not reactive.
Precisely. You'll get the benefits, the steps involved, why it matters for keeping things safe and reliable, especially with complex systems.
Hopefully give people that aha moment about how companies try to, stop things from breaking.
Yeah, that's the goal, shifting from fixing messes to preventing them. So should we dive in? What is FMEA, basically?
Okay, yeah. Let's start there. So FMEA, think of it as a really structured way, like step by step, to figure out all the possible ways something could fail.
Something like a product design or a process.
Exactly. A design, a process, a product, even a service. And the key is finding these failures before they actually occur.
It's like preemptive problem solving.
Yeah. Like sending in a detective team before the crime happens, looking for all the potential weak spots.
Okay, I like that analogy. And it has a few main goals, right? First, just identify the potential problems, the failure moves, as they're called. Second, understand the impact. What happens if it fails? That's the effects analysis part.
Okay, makes sense.
And third, probably the most important bit, figure out how to stop it from happening. Address the root causes proactively.
And I remember reading, it's not just a one-off thing. Someone called it a living document. What does that mean?
Ah, yes, that's crucial. An FMEA isn't some report you do once and then file away. No.
Okay.
It's meant to be updated constantly. As you learn more, as things change, it tracks the failures you found, what you did about them.
The fixes.
Yeah, the corrective actions, and it becomes this like knowledge base, lessons learned, so you don't make the same mistakes again.
Gotcha. A continuous improvement tool then.
Exactly.
All right, so we'll kind of get what it is. Why is it so important? Why are all these different industries using it?
Well, it really boils down to that proactive versus reactive thing.
Yeah.
It's just massively better to prevent problems. One source had a really striking number.
Yeah.
It said fixing problems once something's already operational out in the field can cost, get this, 29 times more than fixing it back in the design phase.
29 times. Wow, that's huge.
It really is. It's not just a little bit more expensive, it's a whole different ballgame.
Yeah, that definitely hits home. Like fixing a tiny crack versus rebuilding the whole wall later.
Perfect analogy. And it ties directly into something called the cost of poor quality. COPQ.
COPQ.
Efficient companies, the ones really on top of things, might keep those costs down to maybe 1% of revenue.
Right.
Less efficient ones could be looking at 5% or even more. That difference, that 4%. For a big company, that's millions, billions maybe.
So FMEA isn't just about like preventing headaches. It's serious financial sense.
Absolutely. It's good business, plain and simple.
Okay. So big cost savings. What other benefits are there?
Oh, plenty. Beyond the money, you see big jumps in reliability. Just things work better, more consistently.
Better quality then.
Higher quality, definitely. And crucially, better safety. If you're catching potential failures early, especially safety-related ones, well, that's invaluable.
Yeah, and put a price on that.
Exactly. Plus, you're reducing the chance of failures actually happening. And like we said, that living document, it builds up this documented knowledge base, super useful for the future.
Right, prevents reinventing the wheel.
And all of this ultimately leads to happier customers, better products, better services. They notice.
Makes total sense. So when do you really need to do an FMEA? It sounds useful almost any time, but are there specific points where it's like non-negotiable?
Yeah, definitely key times. First off, brand new products or processes, that's prime time. Do it from the start.
Get it right from day one.
Yep. Also, anytime you modify something that already exists, even small changes can have unexpected ripple effects, so
Right.
redoing the FMEA is smart.
Okay. What about rules and regulations? Does that force people's hands?
Oh, absolutely. In lots of industries, think automotive, aerospace, pharma, medical devices, FMEA is often mandated. You literally have to do it to comply.
Ah, okay. So regulatory compliance is a big driver.
A huge one. Those industries have super high standards for safety and quality, and FMEA is how you demonstrate you're managing risk proactively.
What if something already went wrong? Is it too late then?
No, not at all. Actually, doing an FMEA after a failure is a great way to figure out the root cause, really dissect what happened and make sure it doesn't happen again.
Turn a problem into a learning opportunity.
Exactly. Beyond that, it's just core to good risk management, especially for complex systems where parts interact in weird ways. Also useful when you're trying to cut costs, make sure you don't accidentally hurt quality. Or before you ramp up production.
Scaling up, yeah. Things can break at volume.
Right. And it's central to continuous improvement programs. Oh, and sometimes your customers might actually require it, especially business to business.
Wow, okay. So lots of trigger points. It really does seem essential. Let's get practical then. How do you actually do an FMEA? I saw a 7-step process mentioned based on AIAG and VDA standards.
Yes, that 7-step process is a really solid framework. Let's walk through it. Step 1 is planning and preparation.
Laying the groundwork.
Exactly. You can't just jump in. You need to define the scope. What are we looking at? What are the boundaries? What's in, what's out?
Okay.
Then the purpose. Why are we doing this FMEA? Set the timing, figure out the team who needs to be involved, outline the tasks, choose your tools.
The 5 T's I think I saw.
That's the one. Intent, why, timing, when, team who, task what, and tools how. Getting that clear up front is absolutely critical for success.
Makes sense. Solid foundation first. What's step 2?
Step 2, structure analysis. This is where you break down the thing you're analyzing, like map it out.
Like an organizational chart, but for a product or process.
Kinda, yeah. You identify the main system, the subsystems, the components. If it's a design FMEA, a DFMEA, you look at how parts connect, interact, clearances, all that detail.
Okay.
If it's a process FMEA, PFMEA, you map out every single step, every sub-step in the operation. Tools like structure trees, block diagrams, flow charts, they really help visualize it.
So creating a detailed blueprint.
Yep.
Got it. Step 3.
Step 3 is function analysis. Now you know the structure, you figure out what each part is actually supposed to do. Its function.
What's its job?
Pretty much. And how do you measure if it's doing its job right? What are the performance criteria?
Okay.
For a DFMEA, you link the function to the higher level assembly, the part itself, and the lower level parts it affects. For PFMEA, it's about the function of the overall process, the specific step, and the work elements within that step. You're defining what good looks like for every piece.
Right. Understanding the intended purpose of everything. What's next?
Step 4, failure analysis. Okay, this is where you start thinking about what could go wrong.
The heart of it, really.
Absolutely. You build the failure chain. 3 parts. First, the failure mode. How specifically does it fail? Does it break? Does it slow down? Does it do something unintended?
Okay, like loss of function or degraded performance.
Exactly. Things like that. Second part of the chain, the failure effect. What are the consequences? What happens downstream if that failure mode occurs?
The so what factor.
Yep. And third, the failure cause. Why did it fail? What's the underlying reason, the mechanism behind the failure mode? You got to dig deep here.
So how it fails, what happens, and why it happens.
Got it.
What comes after identifying all that?
Step 5 is risk analysis. Now you take all those potential failures you identified and you prioritize them. Which ones are the biggest concerns?
How do you figure that out?
Traditionally, people use something called the risk priority number, or RPN.
RPN.
You calculate it by multiplying 3 scores. Severity, how bad is the effect if it fails? Occurrence, how likely is the cause to happen? And detection, how likely are you to catch it before it causes trouble?
Severity times occurrence times detection. SOD.
Exactly. Gives you a number. Higher number, higher risk. Simple idea.
But I think I read there's a newer way, too. Something about prioritizing severity more.
That's right. There's a shift happening. While RPN is still used, the newer approach, particularly with the AIAG and VDA FMEA handbook, really emphasizes severity first.
Why the change?
Well, the thinking is if a failure effect is really severe, like a safety issue, you need to address it almost regardless of how likely it seems or how easy it is to detect. You can't ignore high severity.
Makes sense. Some risks are just unacceptable.
Exactly. So instead of just the RPN number, they use action priority, or AP. It categorizes risks as high, medium, or low based on combinations of S, O, and D.
High, medium, low, HM.
Right. And crucially, a high severity score, say 7 or above on a 1-10 scale, often automatically puts you in high action priority, meaning action is required. No ifs, ands, or buts.
Okay, that feels like a more robust way to handle the really critical stuff. So once you've identified the high priority risks using AP, what's step 6?
Step 6 is optimization. This is the action part. You found the big risks, now what are you going to do about them?
Develop the fixes.
Right. You develop action plans. These could be prevention actions, things to stop the cause from happening in the first place. Or they could be detection actions, ways to improve how you spot the failure if it does happen.
Okay, prevent or detect.
Yep. And for each action, you need clear responsibility, who owns it, and a deadline, when will it be done.
Accountability. Crucial.
Absolutely. And then, importantly, after the actions are done, you go back. You reassess the S, O, and D scores. Did the action actually work? Did it reduce the risk? You recalculate the AP.
Closing the loop. Verify the fix worked.
You got it. That feedback loop is vital.
Okay, makes sense. And the final step, step 7.
Step 7, result documentation. Basically, write it all down.
Paperwork part.
Well, yeah, but it's important paperwork. You summarize everything. The scope, the big risks you found, the actions you took, how effective they were.
Lessons learned.
Definitely lessons learned. Any insights, future plans? This documentation is the official record. It's how you communicate results, and it's that knowledge base we talked about for future projects. Don't skip this step.
Right. Capturing the knowledge. That's a really clear walkthrough of the process. Thanks. Now, we mentioned different types of FMEA earlier, DFMEA, PFMEA. Can you quickly recap those?
Sure. The main ones you'll hear about are design FMEA, DFMEA. That's done during design, focused on the product or service design itself, finding flaws there.
Before you build it.
Ideally, yes. Then there's process FEA, PFMEA. That looks at the manufacturing or operational processes, how you make the product or deliver the service. Finding risks in the steps involved.
Okay, design versus process.
Right. You might also see a functional FMEA, or system FMEA, SFMEA. They take a higher level view, looking at overall system functions early on. And software FMEA is obviously huge now, focusing specifically on code and software systems.
So you pick the type based on what you're analyzing.
Exactly. Match the tool to the job.
Now, doing FMEA sounds great, but are there common ways teams mess it up? Pitfalls to avoid?
Oh, definitely. Big one. Doing it too late. If the design's already frozen or the production line is built, making changes is way harder and more expensive. Early is better. Much better.
Okay, timing is key. What else?
Lack of clear accountability. We touched on this. If no one specifically owns the actions to fix the risks, they often just don't happen.
Right. Needs ownership.
Another mistake is treating it like a one-time thing, that check-the-box mentality. It needs to be that living document we keep mentioning, update it.
Keep it current.
Also, poor documentation. If it's sloppy or incomplete, you lose all that future value, the lessons learned. And finally, maybe the trickiest one, core root cause analysis.
Not digging deep enough.
Exactly. If you only address the symptom, not the real underlying cause, the problem will likely just come back in a different way. You haven't truly fixed it.
Those are really good points. It's not just the process, but the quality of how you execute it. Now, you mentioned digital manufacturing earlier. How is technology changing FMEA?
Yeah, this is a really interesting shift. Traditionally, FMEA could be very manual. Spreadsheets, paper forms, information kind of scattered.
I can imagine lots of data entry.
Right. But now there's this move towards model-based definition, or MBD.
MBD.
Basically, you use the 3D CAD model as the single source of truth. It doesn't just have the shape, the geometry. It also includes all the manufacturing info, tolerances, materials, PMI, product manufacturing information.
So everything about the part is in the digital model.
That's the idea. And you can embed the FMEA information right there, too. Link the risks, the failure modes directly to the features in the model.
So it's all connected.
Exactly. It breaks down the silos between design, manufacturing, quality. Everyone's working off the same digital master. It saves a ton of time, reduces errors from copying data, makes the whole FMEA process faster, more consistent.
That sounds way more efficient.
It really is. And there are standards emerging like QIF, the Quality Information Framework, that help manage and exchange all this digital quality data, the MBD, the control plans from the FMEA, measurement results, stats. It's creating this whole digital thread.
The digital ecosystem for quality.
Oh, cool.
Go.
Wow.
Okay, let's pivot slightly. Healthcare. We mentioned JCI and NABH. How does FMEA fit into their world of patient safety and quality?
Well, even if those specific source snippets didn't explicitly say you must do FMEA for process X, the entire philosophy of JCI and NABH aligns perfectly with it.
How so?
Their whole reason for existing is improving healthcare quality and, critically, patient safety. FMEA is a tool designed specifically for proactively identifying risks to prevent harm. It's a natural fit.
So think about hospital processes, like giving medications.
Exactly. Medication administration, blood transfusion, surgical safety checklists. These are complex processes with potential failure points. FMEA is tailor-made to analyze those processes, find the risks, and figure out how to make them safer before a patient is harmed.
So the goal is the same, even if the specific tool isn't always mandated by name in those standards we saw.
Precisely. When hospitals talk about aiming for world-class care or boosting patient safety efforts to get JCI accreditation, like those examples we saw, you can bet they're using proactive tools. FMEA would be a very logical one to have in their quality improvement toolkit.
Right.
And remember that quote about JCI being a team-building exercise that improved communication?
Yeah, from the Hong Kong Adventist Hospital CEO.
That also points to the value of systematic processes like FMEA. They force different departments, different roles, to talk to each other, to collaborate on identifying and solving potential problems. That improves coordination across the board.
That's a great point. The process itself builds better teamwork and communication around safety. It all seems to point towards this proactive, systematic thinking being key in healthcare.
Absolutely. The drive for safety and quality practically demands tools like FMEA, whether it's explicitly required by name or just part of a comprehensive quality system.
Okay, this has been really insightful. Let's try and synthesize this. If you had to boil it down, what's the key takeaway for listeners about FMEA?
I think at its core, FMEA is really about changing your mindset. It's about deliberately, systematically looking for trouble before it finds you.
Anticipating problems.
Exactly. Thinking critically. How could this go wrong? What would the impact be? Why might it happen? Whether you're designing a widget running a factory or taking care of patients. By doing that analysis, you can take smart, proactive steps to reduce risk and just make things better, safer, more reliable.
And it's not just for engineers or hospital administrators, is it? The thinking seems broader.
Oh, absolutely not. Think about software development, finding bugs early, project management, anticipating roadblocks, even like personal planning.
How so?
Well, you could think about a big personal goal. What are the potential failure modes? What could derail you? What are the effects? What are the causes? Then you can build strategies, corrective actions to mitigate those risks. The core logic is surprisingly universal.
That's a really interesting way to frame it. A kind of proactive problem-solving toolkit for, well, almost anything complex.
Pretty much.
Okay, so final thought for everyone listening. Now that you've got a sense of what FMEA is about, this proactive risk assessment, where in your own world, maybe professional, maybe personal, could you apply this thinking? What's one area where proactively looking for potential failures might help you avoid future problems or achieve better results? Maybe reflecting on a past challenge through this FMEA lens could offer some new insights, something to mull over. Thank you for joining us for this deep dive.